You're watching the Skywatch Media News channel for April 9th, 2019. Here's what's happening. On April 6th, another large meteor exploded in a ball of fire over the Siberian town of Krasnoyarsk. The daytime fire event was caught on dashcam cameras as the meteor streaked across the sky. According to eyewitness reports, the meteor suddenly appeared in the sky as an orange fireball with an intensely bright sparkling tail, accompanied by a high-pitched sound. The phenomenon caused fear on the ground, described by onlookers as similar to a plane on fire. The object split into several pieces before disappearing in the sky, somewhere over the Irkutsk region. This is the third major meteor event in Russia in just over 3 months. On December 18th of 2018, a massive 173 kiloton bolide exploded over the Bering Sea, near the Kamchatka Peninsula. The event was kept under wraps by NASA for nearly 3 months. Then, on the 15th of March of this year, a meteorite slammed into the Krasnoyarsk region, with local reports saying it warmed the air and shook the ground after streaking across the sky in a green, yellow, and orange fireball. The meteor came down close to the site of the Tunguska event of 1908, when a meteor exploded in the atmosphere, wiping out 80 million trees, and with the estimated force of 185 Hiroshima bombs. The rash of recent meteor explosions in our atmosphere is a wake-up call to all nations on Earth. In February 2014, just 1 year after the impact of the Chelyabinsk meteorite, scientists stated that the danger of small asteroid impacts was foremost in the minds of public officials worldwide. The asteroid that exploded above Chelyabinsk in February 2013 was 56 feet in diameter and it weighed 11,000 tons. It struck Earth's atmosphere at 40,000 miles per hour and it broke apart about 12 to 15 miles above the Earth's surface. The energy of the resulting explosion exceeded 470 kilotons of TNT. Masked in the chaos of the explosion was an enormous plume of dust left behind in our atmosphere. The cloud of dust from the Chelyabinsk impact, which consisted of hundreds of tons of material, lingered for months after the explosion, creating a dust belt 25 miles high in the Earth's atmosphere. The dust was traveling towards the east at 190 miles per hour. A simulation provided by the NOAA, as observed from an ozone satellite, provides a realization of the lingering plume created by the large bolide after its impact in the Earth's atmosphere.
It's early morning on February 15th, 2013. A meteor weighing 10,000 metric tons is about to explode nearly 23 kilometers above Chelyabinsk, a densely populated Russian metropolis. Shortly after local sunrise, a blinding sight for thousands of spectators on the ground. A massive explosion equivalent to 440 kilotons of TNT. Hundreds of tons of debris released and quickly moved up into the atmosphere. The highly sensitive OMS instrument on board the Sumy MPP satellite made its first observation of the plume nearly 3.5 hours later, an entire 1,100 kilometers east of the explosion and already at 40 kilometers altitude, well into the Earth's stratosphere. A surprising observation, since the stratosphere usually acts as a bumper that caps aerosols trying to rise up from the lower atmosphere. By inserting a column of data from the first plume observation into 2 NASA models, scientists were able to project the plume's trajectory. The model showed that the plume at higher altitudes, shown in red, would move ahead of the lower layer, shown in yellow. The reason would be the difference in wind velocity at the lower and higher altitudes. When OPS made its second observation, back at Chelyabinsk, Nearly 5 hours after the bolide, there was still evidence of the plume at a lower 30-kilometer altitude. On February 16th, one day after the bolide, the OMPS instrument detected the far end of the plume even further at 1,100 to 2,700 miles eastward from the explosion. By February 19th, 4 days after the explosion, the satellite observation showed that the meteor debris had circumnavigated the entire globe and returned to Chelyabinsk, forming a complete global belt. The clean shape of the belt was another surprising prediction, considering that northern hemisphere winds during the winter are usually rather inconsistent in direction. A further look into the model simulation showed that evidence of the plume would persist for a long time, which also coincided with the satellite observations. We have now seen how accurately the models were able to project the plume's trajectory. This is critical, since the same models are used to study climate and ozone depletion. The unprecedented sensitivity of the OMPS instrument and its ability to see vertical profile of the atmosphere helped scientists track and study the meteor plume for months, revealing a much better picture of what the aftermath on the atmosphere could be from potential future and even bigger such events.
In October of 2013, scientists raised a large piece of the Chelyabinsk bolide from a nearby lake in which it had crashed. According to the Lunar and Planetary Institute located in Houston, some of the pieces inside that meteorite were formed in the first 4 million years of solar system history, from a massive asteroid some 60 miles wide that had been nudged out of the main asteroid belt into an orbit that crossed near Earth. In the wake of the Russian event, authorities from FEMA made an emergency move by attending a planetary defense conference, which is otherwise reserved for scientists. In addition, the White House asked Congress for additional funding needed for asteroid detection, while NASA launched a program devised to gain input from the public, from industry, and from educators on asteroid protection methods. The Earth is continuously being bombarded by rocks and smaller objects from space. But in recent years, the numbers and the size of these celestial objects has been increasing. With every near miss that is being reported these days, we sometimes get the feeling that it's better to not know what is going on above our heads. That may be wishful thinking on our part, given the fact that there have been some truly terrifying asteroid impacts in our recent history. If you think about it, we are sitting ducks on this planet. We never know when the big one will hit. There has been a number of asteroid near misses in recent years. One of those near misses took place nearly 1 year ago on April the 15th, 2018. When an asteroid named 2018 GE3 zoomed past our fragile planet at a distance of just over 119,000 miles, about half the distance between the Earth and the Moon. Its diameter was thought to be between 157 and 360 feet, making it larger than the Tunguska asteroid of 1908. What was so alarming about this flyby was that it was detected only 21 hours before its closest approach to Earth. In November of 2017, an asteroid that no one saw coming narrowly missed the Earth. The asteroid 2017 VL2 measures between 50 and 100 feet in diameter, and it crossed the Earth's orbit at a distance of 73,000 miles at a speed of over 19,000 miles per hour. An impact Earth calculator located at Purdue University estimated that had this asteroid impacted the Earth, it would have had the energy of 220 kilotons of TNT, or 15 times stronger than the Hiroshima bomb. The graphic simulation depicted here is showing how large the resulting crater would likely have been had it struck the Earth. Even more disturbing is the fact that this asteroid was only seen in our rearview mirror, detected by NASA astronomers in Hawaii the day after it had already passed Earth. There are other examples of near-Earth objects whose orbits have taken them incredibly close to our planet. With every asteroid that passes close by and every meteor fireball that impacts our atmosphere, it's becoming increasingly apparent just how fortunate we have been. But will we be as lucky when the next one arrives? Many of you may have a passionate preoccupation with the sky and all of the stars that exist in a universe that has no borders. We spend quiet moments in communion with our Creator who dwells within the vastness of the cosmos, and we always are drawn back to where we come from. Like a homing impulse, we seek out the place of our origin, where life began and from whence we shall one day return. Thanks for watching.